Okay, this experiment was our first titration. We wanted to standardize a HCl solution against a given sodium carbonate solution. So the sodium carbonate solution is our standard solution, so we know the concentration of that solution. We do a titration then to find out the concentration of the hydrochloric acid as well. This is our chemical equation that we're going to use. So we're titrating this sodium carbonate against our acid HCl. That produces salt, water and carbon dioxide. So acid and a base usually produces a salt and a water. So then we should go to here in our calculations, and now we've filled in the molarity of the sodium carbonate. We've gotten that molarity from our previous experiment. So if you flick back a few pages, you should have worked out all here the concentration of the sodium carbonate, and this is it here. Now your numbers might be slightly different depending on the weight that you weighed out. Okay, so you're returning back to get the molarity of the sodium carbonate for this section here. The volume of the sodium carbonate pipetted into the conical flask, you should have used a pipette for that, and we have 25 centimeters cubed pipettes in the lab, so that's going to be 25 centimeters cubed. Then you should have produced 3 different titrations, and hopefully 2 of the titrations should be in agreement of around 0.1. So you can see in the first titration here they overshot it. That's going to be their rough titration. And we're going to take the 2 titers that are closest together, add them together, so 18.1 plus 18.2, and divide that by 2. That'll get you the average titer of the HCl. So that's going to be our volume for the acid, and this is our volume for the base. The indicator used is methyl orange, as we have a strong acid and a strong base that we've titrated against each other. So this is the formula that we usually use for acid and base titrations: VA-MA-NA, VB-MB-NB. So VA stands for the volume of the acid, molarity of the acid, and the number of moles of acid. You get that number of moles from the chemical equation up here. So see how there's a big 2 there? That means 2 moles of HCl would react with 1 mole of sodium carbonate in that ratio, 1:2. So Na is going to be 2. Vb is the 25 centimeters cubed. Molarity of the base we don't know. And Nb is the imaginary one there beside the base. That's going to be Nb. So if you fill in your own values down here, remember this value, you would have a different concentration for your sodium carbonate probably. Vb should be the same. Na is 2, Nb is 1, and depending on what your titration values were, this value here is going to be slightly different as well. So just taking the average of your 2 closest titers for that one. And we move over, and it's time to do our actual calculations to find out the molarity of this HCl. So if we use that formula that we have on the previous page and fill it in as much as we can. We don't have the molarity of the acid, that's what we're looking for. The volume of the acid, that's your average titer, so you might have a different value there. The number in front of the acid in the chemical equation is 2. Your molarity of your base that you made up is here. Remember, that might be a different number. We used a pipette to measure out 25 centimeters cubed of it. And the number in front of the base is 1. So if you put this into the calculator, press the equal sign, bring this 2 across, and that'll be multiplied by all of this, then divided by 18.75. You'll get the molarity of the acid to be, in my calculation anyway, 0.11 moles per litre, or you could say 0.11 molar. Either one of those. And that's it done. So this is a handy formula to find out the molarity of an acid or base, if that's the only variable that's missing. So this is usually the formula that's used for all of your titrations.